So, welcome back, guys. In this lecture, we'll discuss about steady state analysis. So, what is the steady state analysis of second order system response? So, as we already know, we'll just discuss the time response. So, we discussed about the specifications of this time response. Now, we'll deal about what is up to transient we dealt, that is peak time, rise time, settling time, and peak overshoot and all. And we have now we'll discuss about steady state response, steady state analysis. Okay. So in this steady state analysis, the important major thing we have a steady state error. Okay. What is this steady state error? In simple words, steady state error is a difference between the actual output. So difference between the actual output and the desired output. So what is that? The actual output and the desired output. Okay, in again simple way, we say this. Again, I'm taking one RC circuit for understanding. So my 10 volts. So I want to take the voltage across capacitor. Let us say. Okay. So the desired output across the volt in steady state is what? Since it is open circuit, the actual desired is 10 volts only. Okay. So 10 volts is my desired output and desired output, but actually in practical we obtain about 9.8 or 9.9. So let us say put 9.8 and then what is the error? I'm getting 0.2 volts. Okay, that is steady state error. Okay, it is a difference between the actual output and the desired output. So in mathematically, if you want to say that, if you want to clear that, so in this general we have a system, control system G of s, H of s, and we have a feedback H of s. Okay, so if want, this is R of s and this is C of s, and we have negative or positive feedback. Okay, so at this B of s feedback signal is what? H of s and C of s, and this is my error signal. Okay, so the error signal can be given as what? R of s minus BS of s, that is R of s minus C of s and H of s. So this is my error difference. Okay, so if you take the Laplace of inverse, so Laplace of this is of what? Laplace of e power t. Okay, e of t. This is for non-unity feedback. So this is H of s is function. This is non-unity system, right? Non-unity feedback. If my feedback is unity, then E of s I'll obtain R of s minus H of s. Okay, this is steady state error. So the steady state error is the difference between E of s, H of s is 1, so I'm getting C of s. Okay, R of s minus C of s. It is a, so for a step input, which is also a desired output, so R of s is my step input. Actually my response has to settle exactly at R of s, but we can say it is desired output as R of s, and the response C of s we have done. The difference of this is called a steady state error. Okay, this is for non-unity feedback and this is for non-unity feedback. Now coming to the derivation part of this steady state error. So what is the derivation part means? If we have a system, so in response way, so this is we did in a steady state format, but in response way, for a different input, if we have a different so derivation of steady state error. So derivation of steady state error. So in general we have a system, as all we know that. So C of s and this is my h of s, okay, and the r of s. So as we know that here we have error signal, and b of s is a feedback signal, and the error e of s equal to r of s minus b of s, and substitute this b of s here, and you have e of s equal to, so you have the b of s value is what, here we have b of s, the b of s is h of s, and c of s, you substitute this here, r of s minus h of s, c of s. Then from this we have again c of s is what, means e of s, c of s, this one e of s into g of s, I hope you all know this. E of s is error signal and b of s is the feedback signal, and substitute this here. So we have r of s minus h of s into e of s, g of s. Okay, so take this e of s at this point other side, so e of s plus e of s, h of s, g of s equal to r of s. So we need error signal e of s, so for this we have e of s common, so 1 plus h of s, g of s equal to r of s. So the error signal e of s with the reference input r of s by 1 plus h of s and g of s. So this is for what? So if h of s is non-unity, for that means non-unity feedback system. So with the error signal e of s is, this is what with the desired output and desired actual output, and this is what means with respect to the input we'll find some error signal. So okay, in s domain, this is not in time domain, this is in frequency domain. Okay, now for a unity feedback, so that means for unity feedback what you do, we have to keep h of s equal to 1, so we will have r of s by 1 plus g of s. Okay, now my thing is, we need to find error signal in time, that means c of t should we get. Okay, the response should be observed always in c of t. So the actual output for time tend to infinite. Okay, what is that meaning? That meaning the response from 0 to it is getting infinite. So for example, let us say so I started my journey, so the output response is reached like this. So at finite time, let us say at time t equal to 10 seconds, it reached a steady state. Now it reaching steady state for infinite time also, the value is same. Okay, now for this system, to find the steady state error in time domain, so I'm writing this, the steady state error. So what is the steady state error? Means ESS, so listen carefully guys, ESS into limit of E of t, but t tends to infinite. Okay, limit of E of t, t tends to infinite, that is the error t tends to infinite we are finding. Okay, so that means what will have, so E of s equal to limit of E of t tends to infinite, then so limit of, so as in final value theorem we have what in, it is in time domain, so you want it is in function, so as a final value theorem will include s here, so E of s, now s tends to 0. Okay, so in time domain we are finding the steady state error value This is in time domain. So in according to final value theorem, the system is Laplace of this means is to include S. Okay, so this is actual. So if you substitute E of S here, what you'll have? So E of S is equal to limit of S tends to infinite, S tends to 0, S into, substitute this here, R of S by 1 plus G of S. Okay, this is for non-unity feedback. Okay, if the system is non-unit, then limit of S tends to 0, S into R of S by 1 plus G of S into H of S. Okay, this is for non-unity feedback. So that means if anyone gives you their input, now in your hand we have steady state error value. So we have a steady state error in time domain is limit of S tends to 0, S into R of S by 1 plus G of S into H of S. That means to find the error, that is, we need what? Only response input and the system. So if we have the system and the input, and we can find the steady state error with this simple equation. Okay, for non-unity feedback system, that is the main thing. Okay, so now further we have a few things to know. That is next one is, this is the derivation of steady state error. The derivation of steady state error is this is we obtained. Okay, so I said many times, so we'll deal with the type of the system and the order of the system. So here G of S means what is the type of the system, and R of S in the response type of the input. Okay, before going to that, we have another topic called static error coefficients. Okay, so we'll learn about this error coefficients in next lecture. Thank you guys.